Okay, here's an example where we're going to use these properties that we've been learning. So given the log base b of 2, given that that is about 0.356, and log base b of 3 is about 0.565, approximate the value of log base b of 36. So basically what we want to do here is write 36 as a product of some powers of 2 and 3. We can just do the prime factorization of 36, which is going to be 2 times 18, which is 2 times 9, which is 3 times 3. So 2 times 2 times 3 times 3 is 36. And so we can write log base b of 36 as log base b of 2 squared times 3 squared. And therefore, since that's a product, that argument of that log is a product, we can write it as the sum of two logs. So log base b of 2 squared plus log base b of 3 squared. And then we have an exponent in our argument. We can put it out front and multiply it by the log. So 2 log base b of 2 plus 2 log base b of 3. So now we have it. We have our log base b of 2, which we know is about 0.356. So 2 times 0.356 plus 2 times 0.565 for log base b of 3. And then we can just punch that into the calculator. And so that is equal to 1.842. Okay, change of base formula. Let a and b be positive real numbers such that a is not 1 and b is not 1. Then log base b of x is equal to log base a of x over log base a of b. So why would we care about this? Well, it's because this is going to allow us to take any log with any base and change it to a quotient of common logs or natural logs, because those are easy to punch into the calculator and they're logs that are just more familiar. And so if I had log base b of x, I could write it as log x over log b, where that's just a common log. If I have log base b of x, I could write it as natural log of x over natural log of b. Those are just natural logs. So it's pretty amazing that you can do that. And it can be very useful. So if we wanted to estimate log base 4 of 153 between two consecutive integers, and this is not going to apply what we just talked about, this is something different. We just want to find out what two integers is this value, this log between. So we've got log base 4, so log base 4 of 153. And we want to figure out what two integers is that between, all right? So first of all, we have to remember what it means. What power would we put on 4 to get 153? 4 to the third. What does that equal? Well, we know that's 4 times 4 times 4, which is 64. So that's too small. Let's try 4 to the fourth. That's going to be 64 times 4, which is going to be 256. That's too big. We've actually answered the question, because all this question is asking is, what two integers, two consecutive integers, is that value going to be between? Well, it's going to be between 3 and 4, because 4 cubed is 64. That's less than 153. But if I put the power of 4 on 4, I get more than 153. So the power to put on 4 to get 153 must be somewhere between 3 and 4. So that's the answer. So that's one way to kind of estimate, all right, help me find the ballpark. What exponent do you put on 4 to get 153 about? Well, it's somewhere between 3 and 4. Now we're going to use the change of base formula to approximate log base 4 of 153 by using base 10. So remember, all we have to do is say log 153 over log of 4. So that's log of the number divided by log of the base. That's what we just learned on the previous slide. So I can punch that into my calculator because common logs are on there. And I would find out that log 153 is about 2.18. And then log of 4 is about 0.602, about 3.63. So that is right between 3 and 4. Use the change of base formula to approximate log base 4153 by using base E. All right, so we're just going to do the same thing. Natural log of the number 153 over natural log of the base 4. I can punch that into my calculator. Check the result by using the related exponential form. So what they're saying is 4 to the 3.63 power, did we find the right exponent? So if you punch that in, you do get 153.28. So it is about 153. It's not exact because we didn't give the exact answer because it was a big, long, probably, I guess it was an irrational number.